Hey guys, and welcome back. Today we're looking at graphing simultaneous inequalities. That is, graphing several linear inequalities and identifying the regions that they bound. For this lesson, you should have a general knowledge of graphing straight lines. If you need some lessons on graphing lines, I'll link them down in the description box for you below. Otherwise, let's just get started. Personally, I like it when the formula for the line is in this format. Y equals some number of x plus or minus some value. This is the gradient and y-intercept format, and it tells me just by looking at it what the line will look like. The c, or the number that is added or subtracted off, is the y-intercept. That's where my line will cross the y-axis. And the m, the number in front of the x, so the number of x's we've got, is the gradient. That's the steepness of my line. So for example, y equals x minus 4 has got a y-intercept of -4. So directly I can plot that on my graph. On my y-axis here, where y is equal to -4, my line is going to cross the y-axis. And my gradient, don't think that there's no number in front of the x here. If there's no number in front of that x, surely there is one x. Otherwise, there would be no x at all. So here my gradient is 1. Now, a gradient is the steepness of a line, which could be expressed as a fraction, which tells us how far we need to rise up as we run across. In the case of a gradient of 1, when I run across 1, I'll rise up 1, because 1 divided by 1 gives us our gradient of 1. Similarly, I could run across 2 and rise up 2, because a rise of 2 over a run of 2 again has a value of 1. So I could go ahead and graph my line here, which crosses through the y-intercept at -4. I go across 1 and up 1, that's my next point. Across 1 and up 1, that's my next point. And you can see as I plot these points across 1 and up 1, I'm making this straight line. This line here is the line y equals 1x minus 4. I've got a y-intercept down here at -4 on the y-axis, and the steepness of the line is 1. We can also graph lines when they're not in that format. This example here is in the standard x-intercept and y-intercept format, because it's in the best format to find both of these intercepts. I've got some number of x plus some number of y equals some number. I can easily find what x will be when y is equal to 0 and what y will be when x is equal to 0. So let's give this a try. If x is equal to 0, in this equation, 2 times 0 plus 3y is equal to -6. Notice I've just replaced this x with a 0 using brackets, not to confuse that with 20. And this is 2x, which means 2 times x, so I'm doing 2 times 0. Now 2 times 0 is 0, so that'll give me 0 plus 3y equals -6. And now I just want to work out what y is. When x is equal to 0, 3y must be equal to -6, which means the y on its own is -6 divided by 3, which is -2. So my y-intercept is -2. When y is equal to 0, I can find my x-intercept. So when y is equal to 0, in this same equation of a line, let's replace this y with a 0, and that does not make this 30, this makes this 3 times 0. So we've got 2x plus 3 times 0 is equal to -6. Now working this through to find out the x-intercept, so the x value when y is equal to 0, 2x plus 0 would be equal to -6. So 2x is equal to -6. So x is equal to -6 divided by 2, which is -3. So I'll plot my x-intercept on my graph as well. And having this x-intercept and this y-intercept, I can draw a straight line between these 2 points. And that's my line 2x plus 3y equals -6. Now we could also graph this the previous way if we started by rearranging this equation to get y as the subject. So let's try that now, just so that we can compare our line with our gradient and y-intercept that we had in the other format. So to get y on its own, let's first send the 2x to the other side. It was positive, so now it's going to become negative. Let's get the y completely on its own. There's a 3 multiplied by this y, so let's divide by 3. Now the -6 can divide by 3. but the negative 2x will simply be left over 3. So I have negative 2 minus 2x over 3. Now just to get this in the y equals mx plus c format, let's turn these terms around. Y is equal to negative 2 over 3, x minus 2. So I can see now that my y-intercept is negative 2, and look at my line. It does cross the y-axis at negative 2. And I can also see that my gradient is negative 2 over 3. It means I'm going down. So as I go 3 unit steps out to the right, I fall down 2 unit steps. Right? That works from any point along this line. From this point here as well, if I take 3 unit steps out to the right, I fall down 2 unit steps. So that's definitely a downward sloping line. That is a negative gradient of negative 2/3 and a y-intercept of negative 2. Now that I've graphed 2 lines, you might be familiar with solving simultaneous equations this way. I've got my line number 1, which was y equals x minus 4. I've got my line number 2, which was 2x plus 3y equals negative 6. And I can see that the solution to these simultaneous equations is the one point, so the one combination of x and y values that obey both of these rules. That is, they fall on both of those lines. Now, it might be difficult to see from my graph, but that point there is where x is equal to 1.2 and y is equal to negative 2.8. That's the coordinate point 1.2, comma, negative 2.8. But we're not looking at simultaneous equations today. We're looking at simultaneous inequalities. So to solve simultaneous inequalities by graphing, again, we'll start by graphing those lines as we've just done. However, we're not interested on the points on those lines. We're interested in the points above or below those lines. For our first line, you can see that y is greater than x minus 4. So I'm looking for the points on this graph that shows y values above the line y equals x minus 4. That is not including the line x minus 4. So I'll make this a dotted line. And I want to shade in the region where y is greater than this line. So y is above this line. Looking at this line and all of the points along this line, these are the points of the line, these are the y values above the line, and these are the y values below the line. I want the y values above the line. Looking at my second line here, now since this is less than or equal to, I'm happy to have a solid line here, but I want to find the region that is below negative 6. Now here is my line. I want the x values, which are less than the x values on the line, so to the left of the line. I want the y values that are below this line, so not above it, but below this line, because they're less than or equal to negative 6. That's the same region as we mentioned with the x values. So we're interested in this region down here. So our solution is not one single point. It's any point that's inside this region that was shaded in pink and shaded in blue. So our solution is the region I'm labeling with this R here. And just to make that really clear, let's make sure that the boundaries are clear. It's the region that is bounded by this line and this dotted line, which means it includes the coordinate values along this line, but only the coordinate values up to this line, not including the ones on the line. Now, hopefully that was fairly clear, because it's time for you to get some practice in now. Go ahead and hit pause so that you can graph both lines. Remember, if the inequality is not underlined, it's a dotted line. If the inequality is underlined, it's a solid line. And pay attention to the inequality to see if y is less than or greater than your expression. The first 4 sets of inequalities are in the gradient and y-intercept format. And the last 4 sets of inequalities are in the x-intercept, y-intercept format. Remember, if there's a format for the equation of a line that you prefer to graph, you can always rearrange these inequalities to that format before you start. Now go ahead and hit pause now Take your time to set that up neatly and hit play when you're ready to take up your answers. I hope you had a chance to hit pause, because here come your answers. For question 1, I hope you've labeled your lines with their equation. This is my positive sloping line, so that should clearly be this equation. And this is my downward sloping line, so clearly that line should have this equation. But these aren't equations, they're inequalities. So hopefully in both cases you shaded where the y values are below the line. For question 2, again, you've got one upward sloping line and one downward sloping line. It should be pretty clear and obvious which is which. And again, we're looking at the inequalities here, and we're shading now where y is above this line and where y is above this line as well. For question 3, this one we have two downward sloping lines, so I hope you labeled them with their equations. The steeper downward sloping line is the one with 7/5. So that's this green one here. The less steep one, of course, is the -4/9. Both of them have a y-intercept of -3, and in both cases, they're solid line because they're underlined. And we're shading the region where y is above both of these lines. For question 4, here we've got one horizontal line. Y is less than -3, so I've got a dotted line at where y is equal to -3, and I've shaded the part below it. And y is less than this positively sloping line with a y-intercept of 3 and a gradient of 3/2. Every time I go across 2, I go up 3. And again, I've shaded the region where y is below that line, so below that line here, below both lines. For question 5, for question 6, for question 7, and for question 8. How did that go for you? Hopefully your graphs match mine. If not, or you have a doubt or a question, please leave me a comment down in the comment section down below. Otherwise, well done, keep practicing, and I'll see you soon.